7.5, dilution of solutions. Now in this section, we're going to just apply math to a concept that you already know. If you are going to dilute your cup of Kool-Aid that you made for your little kid, you know what you're going to do, and you know why. So if you're going to dilute that cup of Kool-Aid, you're going to add water to it. Why? So it's not as sugary overall. And so it is going to be less concentrated. You're going to have more water so that it's not as sugary anymore per sip to the little kids. So here we go. When water is added to a concentrated solution, there is no change in the number of particles of the solute. However, those solute particles spread out as the volume of the diluted solution increases. So the math in this is pretty much the same. So first of all, let's make sure that we understand that in a dilution, water is added. You're going to have an increase in volume, which means the concentration is going to decrease. It's not going to be as sugary. If it was Kool-Aid or whatever the thing is, it's not going to be as much of that. But the mass of the solute remains the same. Why? Because you increase the water. That's why when the mass of the solute remains the same, with increased water, the net result is that the concentration decreased, which is what you wanted in a dilution process. So here's another example. You get the can of orange concentrate, you add the water to get an overall 4 cans of orange juice, which is much better tasting than if you were trying to drink, quote, drink that can of orange juice concentrate. Yuck. So our math, you will notice the similarities. It's the concentration of the first times the volume of the first equals the concentration of the second times the volume of the second. And for molarity, M1V1 equals M2V2, and remember molarity did stand for concentration. So you can see that it really is the same formula that we're going to use for this section. So prepare a table with the concentrations and volumes of the solutions, rearrange the dilution expression to solve for the unknown quantity, and substitute the known quantities into the dilution expression, and solve. So what's the final concentration when a 0.50 liters of 6.0 molar HCl solution is diluted to a final volume of 1.0 liters? Okay, by now you have been bombarded this whole chapter with a whole bunch of different formulas, and you may go, what formula do I use? Well, the key is dilution. Okay, if they use the word dilution or diluted here, then we know we're going to use the concentration, the M1V1 equals M2V2, or, the C1V1 equals C2V2. So the 0.5 times the 6.0 equals the 1 times X. So let's think about this before we even solve the problem. What's going to happen to the concentration in a dilution? Well, we know the concentration is always going to get less. So when you do this math, you better have an answer less than the concentration of the first one, which is 6.0. So you better have an answer less than 6.0. So here we go. We are going to rearrange our formula to solve for the second concentration, because that's what they asked for. Now then, the first molarity, 6, okay, times the first volume, 0.5, divided by 1. So when you multiply all that through, it ends up being 3.0 molar HCl, which, if you think about it, makes sense because we just said that the concentration had to be less when you are diluting the solution. So here we have another problem. What volume of a 2.00% HCl solution can be prepared by diluting 25 milliliters of 14% HCl solution? All right, so we know, here's our key word, dilution, so we know it's our M1V1 equals M2V2, or the same thing, the C1V1 equals C2V2. And they want to know what the second volume is. So here's the information for our first. So our concentration C1, here's our first volume, and then here is our second concentration, and our second volume is what our unknown is. So we're going to rearrange this formula, C1V1 equals C2V2, to solve for our second volume, and then we just plug in our values. So 25 milliliters times 14% over 2% equals 175 milliliters of solution. What is the percent of a solution prepared by diluting 10 milliliters of 9% sodium hydroxide to 60 milliliters? Okay, press pause, see if you can solve this. All right, when we come back, again, we know what formula to use because we read the term dilution or diluting. So we know it's some version of C1V1 equals C2V2 or M1V1 equals M2V2, same concept. We are solving for the second concentration. So we're going to plug in our first concentration, our 9.00, our first volume, our 10 milliliters, over our second volume, 60. And when we solve for that, we're going to get a 1.50% mass per volume solution. What is the molarity of a solution prepared by diluting 0.180 liters of 0.600 molar HNO3 to 0.540 liters? Okay, M1V1 equals M2V2. Let's see what we have. We have, this is our first side, our first volume with its corresponding concentration. This is going to be our second volume. We need to figure out what our second molarity is. So first of all, we know that our second molarity has to be less than our first molarity because why? We're diluting it. Remember, that's our little key there. So see if you can solve this problem. Press pause. All right, here we go. So we have our information, what I just mentioned. We're going to solve for our second molarity. And so we are going to plug it in. So we have 0.600 molar times 0.180 liters divided by 0.540 liters, which is 0.200 molar solution, which, yes, it is definitely less than 0.600 molar. So we know we did the right thing.